Hi, I'm Ken. For question 1, given that 2r plus 1 equals to cosine theta. For part 1 of the question, we need to test the symmetries of the equation. First, symmetrical about x-axis. Substitute negative theta into the equation and simplify it. As we can see that after simplification, the equation is same as the given equation. So, we can conclude that the equation is symmetrical about x-axis. Second, symmetrical about y-axis. For this case, substitute pi minus theta into the equation. After simplification using trigonometric identities, the equation is not same as the given equation. Therefore, the equation is not symmetrical about y-axis. Lastly, we need to test for symmetrical about pool or origin. Substitute pi plus theta into the equation. After simplification, we can see that the equation is also not same as the given equation. Therefore, the equation is also not symmetrical about pool or origin. For part 2 of the question, we need to construct a table for r theta where theta is between 0 degree and 2 pi with increment of pi over 6. Next, and sketch the graph of 2r plus 1 equals to cosine theta. For the table, substitute all the theta into the equation. After the substitution, the table is constructed as shown in the picture below. Next, I will hand over to Ayman. He will continue to explain the remaining part of the question 1. Thank you.
So we put the points on the graph here, 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 and here, and we sketch it. This is the shape of the graph we get. And after that, the question says to sketch the graph r plus sine theta is equal to 0 on the same diagram. Before we sketch, we have to find the center and the radius. So r plus sine theta is equal to 0, and we could multiply r on both sides and get r squared is equal to minus r sine theta. After that, we could write r squared as y, r x squared plus y squared, and r sine theta is minus y. After completing the squares, we can get the circular equation, and we could find the center and the radius. And the center is here, 0.5, which is half, and the radius, the radius 1/2 and center minus 1/2, which is here. So the other part is find the intersection points between curves 2r plus 1 is equal to cos theta and r plus sine theta is equal to 0. In order to do that, we need to substitute equation 2 in equation 1. So cos theta minus 1/2 is equal to minus sine theta. And we could bring the 2 on the other side and get cos theta minus 1 is equal to minus 2 sine theta. And we could divide the whole equation by cos theta and get minus 1 plus, and we could get 1 plus 2 tan theta is equal to 1 over cos theta. After we square both sides, we get 4 tan square plus 4 tan theta plus 1 is equal to sec square. And we could write sec square in, as we look at the formula sheet, as 1 plus tan square is equal to sec square. So we could write sec square as 1 plus tan square. And we could bring the tan square on the other side and subtract it. So here I substituted tan is equal to tan theta is equal to y, and we could just write it this way and get tan theta after getting the y value. After getting the y value, we replace it in the tan theta. As we said, tan theta is equal to y. After getting the y value, we have to replace, and tan theta is equal to 4/3, negative 4/3, so we get negative 53/13. So in order to find the intersection point, we have to replace r is equal to minus sign negative 53.13, and we get r as 0.79, and r is equal to sine 0, which is equal to 0. So the intersection points are 0, 0, and 0.79 minus 53.13. Thank you.
Is B multiplied by C. And then since this is -1 because the second sign is negative, so it will include it. And then 1 multiplied by -1 minus lambda, and get this, and 0 multiplied by 1 is 0. So, and then we just factorize it out. -1 minus lambda, since both side has this number. And then we just solve the other number, and then we will get lambda square minus lambda minus 2 minus 3 minus 1, and then equal to 0. And then for this factorized number, we have to simplify, and then we will get lambda square minus lambda minus 6, and then we factorize it again, and it will get two value. It is lambda minus 3 and lambda minus 2, and then we have to equal to 0 for the 3 value, and then we will get lambda equal to -1 for the first value, and the second one is lambda equal to 3 and lambda equal to -2. So the question asking about the find the eigenvector for the largest eigenvalue. So we have to choose the largest value from the lambda, since 3 is the largest, and then we have to substitute the lambda in the we have to substitute lambda equal to 3 into the equation B minus lambda identity x equal to 0. And then since the lambda is 3, we have to substitute 3 in this lambda, and then we will get -4, 1, 0, 1, -1, 1, 0, 3, -4. And then x equal to 0.
Okay, next from this metric B minus lambda identity, we have to perform a row to obtain a metric. So first row we divide with -4, because the rules of isometric, -4 should be 1. So -4 divided by -4, 1. Then 1 divided by -4, -1/4, and then 0 divided by -4, 0. Okay. Under the pivot point, 1, here should be 0. So row 2, we minus with row 1. So 1 minus 1, 0. -1 minus -1/4 is -3/4, and then 1 minus 0, 1. Next, -3/4 should be 1. So we divide -3/4 with -3/4. 0 divided by -3/4, 0. -3/4 divided by -3/4, 1. Then 1 divided by -3/4, -4/3. Lastly, row 3, we minus with 3 multiplied by 3 row 2. So 0 minus 0, 0. 3 minus 3, 0. -4 minus -4, 0. So the echelon matrix is 1, -1/4, 0, 0, 1, -4/3, 0, 0, 0. So on this echelon matrix, we can write into equation So the question are x minus 1/4y equal to 0. Next, y minus 4/3z equal to 0. So we need to let z equal to t. Then we substitute z equal to t into y and x. So we obtain y equal to 4/3 and then x 1/3t. Next, we have to write x, y, z in terms of t. So we can conclude that the eigenvector for the largest eigenvalue are 1/3, 4/3, and 1. And that's all from us. Thank you.